This is a three-phase motor. We all know that our fan moves the air, whatever we do, but motor moves the fan. It's the heart and soul of our pretty much all our industry, and it's been since design since Tesla did that the early, or actually late 1800s. Design didn't change a whole lot. It's the same basic principle. Start with, okay, now see why it doesn't work. It's a little disclaimer here, pretty much telling you that this is informational purposes only. This is not intended to be a training, it's certification of any kind. Watching this presentation is at your own risk, and using any information provided will justify the existence of this or any other disclaimers. Information provided is for better understanding why you should call a professional when you're encountering any issues discussed or presented in this PowerPoint. ICA, Airclear Technology, or I will not be held liable for any use or misuse of this presentation or any physical, mental, or material damage that has resulted in the misuse or misunderstanding of call the professional. What is electrical motor? It is the device that converts electric power into mechanical motion. That's kind of simple version. That's what should go beyond that. If you want a longer version, it's right below. It's telling you how the electromagnetic works and what it does, how to want to spin. That's pretty much, it will be too techy, too engineering to talk about it. But it's basic to know. You apply the power to the device that converts that electrical power to mechanical motion. There's a two basic enclosure of electric motors: open drip proof and TFC, or totally enclosed fan-cooled motor. ODP motor is open drip proof, where the motor is chambered and has open vents. These ones are on the side, you can see it. And what they do when they work, it moves the air over the windings to keep them cool. This motor is not suitable for everywhere. It cannot be on open space. It cannot be dusty, oily, misty application because they will burn the motor. This is cool for the clean spaces and protective where you want locations. Therefore, use of this motor on direct drives, over-air application. By the way, over-air application means that motor sitting in the airstream or in the airflow is not very good. It will have a problem. And I'll show you an example later what's happened to the motor who died gruesome death by being exposed to the elements. TFC motor, it's a totally enclosed fan-cooled motor. That means this motor is completely enclosed and protected from the elements, from the dust, moisture, from anything that goes in the air. It does using the internal fan that's right in his housing, and I'll show you one later, to cool to blow the air across the housing to cool. If you can see on the picture, those ribs are heat exchangers. Basically, they enhance the space of when the air touches the housing to remove the heat out of the fan himself. This fan could go almost everywhere. Do not submerge underwater, okay? But it could go. This is the internal components of the electric motor. If you see it, it's on the top, it's a housing, it's the body of the motor himself. Inside that body, inside that housing, you have a stator. That is basically all windings that goes around, and it's a bunch of wires. It's just a big, long loop. And there's a 3 of those loops for three-phase motor. Now, with those loops, size of the wire and the number of the wires determine the horsepower of the motor. If you look at the second thing, it's the rotor. This gray area in the middle, it looks solid, but this is thousands of small steel plates compressed together. Number of these plates combined with the number of this winding on the starter determine your revolution per minute, or RPM. Next ones are the bearings on both sides, the motor shaft that goes outside across the starter, wiring device, and that's your basic component. Every motor does have this. There's no difference in the motor. Even a single-phase motor still have a starter, rotor, bearings, housing, that kind of stuff. Motor nameplates. Okay, this is a tricky one. You can see the different motors, different manufacturers with different plates. Nameplates have only one purpose. to tell you what this motor does. If you do have one and you can read information from it, you can be easy. Some of those provide you wiring diagrams, some they don't. But point of no motor plates is to tell you what is motor it does. And nameplate basic informations are: it's horsepower to give you motor effective strength, voltage telling you necessary power for the motor to run, frequency is usually 60 hertz in the United States. Most of the world uses 50 hertz. That tell you how many times per minute AC current is going to go back and forward. Phases, it's a single or three phase. It's got PH1 or PH3. They're going to mark on a motor nameplate. Full load amp. Full load amp basically tell you maximum allowable safe operating amperage of the motor. As the horsepower change, as the voltage change, that full load amp goes up and down based on actual use. And we'll go back to the nameplate. I'm going to show you something there. That when you see 208, and all of this is going to show dual voltages. You have sorry, my bad. Going to show you 208, 230, 460. And you see that the full load amp goes basically, it's higher on the low voltage side and lower on the 460 side. That's directly relationship basically. That's the part called the Ohm's law. Direct relation between the voltage versus the amp versus resistance. Service factor. This is a tricky one. Service factor is basically telling you how much you can go over the full load amp and still be kind of in a safe area. And most of the labels going to have 1.1, 1.15. That's going to give you basically how much more you can kind of push that motor. It is not advisable, especially for no longer a period of time, but it is important to understand. If you need a temporary to run over, this is how much more you can push that motor. It's kind of like a red area in your car. When you step on the gas, when you go in the red, don't go all the way to the end. Stick a little bit there, you might survive. RPM, it's revolution per minute. It's basically speed how is motor rotating. Frame, it's a physical dimension of the motor. We'll discuss that a little bit more later in how much that can help you understanding what that is. You have enclosure, TFC or ODP, we discussed it already. You have open deep proof or totally enclosed fan cooled. Duty. Okay, this is what motors is designed for. You can see that on a label say continuous duty. What that means? That means this motor can run 24/7 without stopping. Or where he invented duty. That means this motor is rated for the VFD, because not all motors are rated for the VFDs. And we go on and on about that. Another one too is code, class, installation, or type. All of these mean same on different labels. It's basically temperature rating for the motor. If motor do have type F insulation, it's compatible with the VFD because it's designed for higher temperature rate. It will actually allow you to work with the VFD. Some other type B, type K, type L will not, because their rating is lower and they will not allow you to do so. You have tendency to burn. Now, this is a basic motor wiring diagrams that show you basic low voltage, high voltage. Some of those are printed on a motor nameplate. Some of those are printed inside the motor box himself, but they're always provided. You'll never buy the motor that they will not show you this. Now, to understand what is a low voltage, it's 208, 230, and 200. 200 is mostly rated for the urban area when we have issues with the power supply. They go 200 low as 200. High voltage, it's a 440, 460, 480. That's mostly industrial applications or high-rise building. Newer one that they do have a higher power source, better power source to provide it more stable. When you're wiring the motors, make sure that you wire for the correct voltage. It's one of the most common reasons why the motor fails. You put the wrong voltage on it, push the button and say poof, it doesn't work anymore. What if? What if a nameplate is missing? We all deal with this. Number one, just run. Don't go back. Go away. Let somebody else deal with it. If you are somebody else, then you need to understand what it takes to figure out what motor is and what motor does. That's where the frame come in place. Because voltage, it's easy to figure out. You know what you supply. You can identify the breaker panel, supply panel. You're going to find that what's a 208 or 460. It's easy. Full load amps, if somebody did his job when they did installation, you can find that either on a VFD setting or what's the setting on your contactor and overload. Frame, for the frame, you can measure the couple or few points on the motor physical side. We're going to go on next page. I want to show you what this means. This is a frame chart that tell you which of these individual components, individual parts of the motor, when you measure it, it correlates to which of these frame numbers. And as the horsepower of the motor change, physical side change, therefore a frame side change. I put some examples here at the most common one, and you can see that some of those overlapping. By the way, you're always going to find the odd one, especially some OEM applications. We're going to have some weird stuff that we're going to say, okay, who will come up with these things? But it is what it is. But it's usually 1 horsepower, it's about 56 frame, 3 horsepower, 143, 145, 5 horsepower, missing here, it's 184 frame, 7.5, 213, 215, 10 horsepower, 215 T. And some of these examples, like I said, it can be exceptions, can go overlap each other, but they're most of here too. And once we go on live, I will show you how to do some of these things to understand which tool to use, how to figure out. Hey, this is the one that we all wanted. You go on a job site, motor's running, fan is running, everything is fine. You shut them off, you finish your work, turn it back on, won't start. And then you're like, what the hell just happened? 90% of time, this is caused by the single phasing or loss or one leg. 3-phase motor must have a 3-phase to start. Once it gets to the full speed, full motion, he can lose one leg and it will still run until you stop it. Once you stop it, it will not start again. That's a Newton's laws of motion. Body who's moving have a tendency to stay moving until you stop it. This moment, you should remember part where you should call professional and find out what's going on. And if you're the one, let's go next page. But again, let me read our friends, and I'll show you example of this live. 3-phase motor, need the 3-phase to start. But if you lose one, it will continue to move until you stop it. And when you try to restart, it will not do it. Period. Single phasing. If you're lucky winner of the single phasing motor, you should look following. This is not all. This is just the most common thing that I run into it. Burnt wire. It can be burned in housing, can be burned somewhere in the wiring. Burnt fuse. That's usually if you have a fusible disconnect switch, you're lucky because it's right there. If it's not, God knows where is it. Good luck. You have to trace the conduit. Connections. Again, it can be from the motor himself all the way down to somewhere in terminal blocks. Burnt wire inside the motor J box. That is one of the most common one that do the overheating or vibration, wire nuts melt, and you burn the wire there, and you lose that connection. Burnt contact. Loose terminal block, fuse block, contactor, it can be loose, it's just over time. One thing that people forget, and if you don't deal with this all the time, you overlook the fact that wires are subject to heating. As the current goes through, excited electrons inside, it's going to heat the wire. As the wire heats up or cools down, slowly it will change the stage, and that little screw that holds them in the terminal block will get loose. You like it or not. That's why occasionally when you do services, turn the power off and kind of retighten everything just to play safe. point burn inside the widening. This one is tricky because if you remember widening, it's a long wire. It can go about 2 miles long inside the motor housing because it's complete, it's very packed and compressed. It can burn in between those widening. Now you have a shortcut. It's no longer a mile long. Now it's half a mile long. But your digital meter is showing you beep. You go against the ground, no problem. Everything is fine. It still doesn't work. That's when you look at when you measure the resistance between the phases, it will show you a difference. Based on horsepower, based on stuff we're going to show you here. But all 3 phases should show you about same resistance every time you measure. If you have an odd one, that is your problem. Because you should not have nothing odd in the motor. It should be even all over the 3 phases. Now you can have a combination of all of these. Happened before. Deal with them. This is what it is. Bad breaker. Very rarely this happen, but it did. I had a breaker that simply one out of the 3 burned, died, bad, whatever. But did not have a third leg coming out. And we traced it all the way down to the breaker panel. Fortunately, it was on a different floor in the building. It took us about a day and a half to trace it because nobody knew where it goes. And we finally found them and find that one of the legs was bad. That's when you call the electrician. Do not open that panel because we're not qualified to do so. Overamping. Problem with overamping happens when the safety device tripped when the actual amp draw exceeded the full load settings. Reason for that can be motor running too fast, you get too hot, and your internal or external cooling device cannot cool down. Motor running too slow. Okay, but motor running too slow, you don't generate enough air movement across the motor to cool down the motor, overheats again, in overhams. Motor is undersized for the application. This one is when you put a 3 horsepower motor on a 10 horsepower application. It's going to struggle, it's going to overamp because it cannot move that air. Single phasing, like we discussed, lose contact, that's what we discussed. Brownout. Now, brownout is, especially in urban areas, I know in Southern California, we had that all the time. When it gets hot, we turn all air conditioning on, and our supply power dropped down below 190 in some cases. And then when you had that little flaring and how's the voltage to go down, your amp's going to go up, exceed the settings, and you're going to trip. Undersized wiring. This happened when the motor is pretty far away from the source. And you with 10 amp, you're on the 10 gauge wire, you're happy camper, you satisfy all your rules, everything's fine. But we have issues. Issue there is the length of the supply wire. And technically on every 50 feet of length, you need to amped up 1 gauge higher or bigger for that wire. If you don't do that, you might have a problem that you're going to lose the voltage loss across due to distance. Overheating, again, we go back on other reasons for overheating. One of the most common too is the motor was in an enclosure that doesn't have any air movement or any fresh air supply in it. We see that quite often. I had an application where we had to poke the holes on the side of the housing to just allow the fresh air to come in. Sometimes there are wrong settings. Somebody did not put the setting correctly, and the system overamping and tripping, even nothing's wrong. They need to check their settings to make sure that they are on the correct range. Bad safety device. This happening when the just fail. Constantly show that overamping, even nothing's wrong, but your safety device is bad and it's tripping. And we can go a lot more of examples about why system overamping. But this is the kind of most common that I deal with it. And if you guys did some more, please pitch in. Motor died. That's when the magic smoke left the bottom and never come back. One of the first biggest reasons, overheating. And overheating can be because it's just material fatigue. It's old, time to die. That thing is run forever, time to go. Poor ventilation. When we don't have a chance, when you have a motor in the wrong application and it doesn't move enough air, it's going to get overheated, it's going to die. Undersize for the application, as we talk, you have a motor that 3 instead of 10, it's going to die because it's going to struggle to move. It's going to eventually die. Running too fast or too slow, that's a problem when I see a lot of time with the VAD application. When I have my air balancing guy, instead to reshift the fan, he put the motor to run on 80 hertz. Motor is not designed to run on 80 hertz. Even it can, even if your full load dump is going to allow, but now your fan does not move enough air to cool that motor. Therefore, a motor should run at 60 hertz and you reshift the fan. Make that fan run correctly. Mechanical obstructions. We see the bearings on the fan fail and the motor until it die too. Now, the second one is overamping. When the safety device fail and do not shut down the motor when it goes to the proper location, proper height, it will kill the motor. Unstable power supply. Okay, power fluctuations over a longer time that exceed 10% of nominal value. That's mean that 208 motor can run on 230, can run on 200, because within 10% of the nominal value. But 230 motor will run on 208, but will not run on 205 because it exceeds that 10%. And that's when the amp's going to apply. When you are in areas when this is a common, and if you run on a low voltage, that's very important to understand. It's much more susceptible to this than the 460 motors. Make sure that you look at the motor ratings and is it ready to run on 200 volts. If it does, you're pretty much safe. Brownouts. Brownouts is when you get the areas below the 200 volts, then everything gets kind of caca and things start tripping, failing, burning, things. Current spike with no power line filters. This is very common in older electrical systems. When your transformer inside your building do not have a power filter, and you're subject to either brownout or subject to power loss, restarting again, that's when they have a current spike. That current spike can burn that motor to the point that that motor can explode if you get too many amps on it. I've seen one in my life, and that's one of the scariest things ever you want to see it. It was really ugly. Continue. Human error. This is by far the most common reason why the motor dies. Start with wire the wrong voltage. When you just, whoever wires don't pay attention to what's going on, and things goes out, or you order the fan of a 460 or 208 electrician put together, don't pay attention to what's on the nameplate, and you just wire the things, turn on, wire and do nothing, things just blow. On the low voltage, you have a mixed wire number 6 and number 9. The little dot on the bottom of that number to show you which number is. Quite often when you're running, guilty of it, you don't pay attention on it, you didn't see it, and you wire those two, it won't burn the motor. Wrong wire nuts. You see the question, how can be wrong wire nuts? Wire nuts is wire nuts. No, they're not. They're not all wire nuts rated equally. Some of those are rated for 200 degrees. That's a standard electrical wire nuts. I will show you that later too. And there's a log wire nuts that are rated for 300 plus degrees that are actually lightning and motor rated. And I'll show you those difference between those two a little bit later. Loose connections, again, human error. Wrong motor for application. I just grabbed something, did not pay attention. What is it? Put them in, it doesn't work. It died because of that. Poor maintenance. Now, our poor maintenance, when we do our fan maintenance, and we look at those little fan cools, little vents holes, they get clogged over the time, and they will. Clean it. If you don't, they're gonna overheat. Ignorance. Now, motor will give you a sign that something is wrong. You go on the motor, it's kind of hot, more than it should be. Get a little smell. You get some stuff that it can tell you, if you don't pay attention on it, motor will die eventually. And guess what? It's your kind of problem that you did not look at on what is going on with the motor. If it's a sitting hot, you cannot touch it. There's a reason for it. look for something. Pop the J-box, see what's going on inside. See there's a connection good. See is there a cooling okay. See there's something obstruction of the airflow for the cooling. There is a reason for that. Motor does not die without reason. It give you those informations before it died. Do it yourself fixing. God bless those people. I see so many stuff. I don't even want to go there, but there's so much Mickey Mouse things going on that things die because of it. And please do not improvise. This is a device that can kill you easily and make much more damage than you need to do. If you're not sure what you're doing, don't improvise. And last but not least, it's up to God. He just died. And usually that happens on Saturday around 6:30 p.m. It's a dinner rush. That's a never missed to happen. This is one of those when no matter what you do, it's going to happen. And make sure you have a spare motor with you. Now we're gonna live for this. It's gonna be a Q&A section. April's gonna help me to figure out how we're gonna do this with the Zoom. But I want to show you some example of the motors, different type of settings, different type of applications, different type of configurations, just for information to see. I want to show you how the motor run on 3 and run on 2. It won't start on it, just to see some stuff that I just said. You can see it. April, can you figure out how we're gonna do this, the full screen? Okay, that's not supposed to see this. Okay, I'm trying to just figure out this. April, can you hear me?
Kathy DeMarco's here, Mario. What is it you're trying to do?
I'm trying to move live myself on the big screen.
You have something else you want to share on your screen?
Yeah, actually, I want to go live that way they can see. I don't need to share the screen anymore.
Okay, click your share screen button, and it should say stop sharing, or you should see a stop sharing button somewhere.
Okay, let me just find my screen. There we go. I'm sorry, guys. This is not supposed to be like this. It's just because one of those things that does this. Where's the stop sharing?
Let me just do this for you here.
Please do, because it's there you go.
There we go.
All right. Cool, guys. Sorry one more time, but I'll try to do this as fast as I can. You can see it. PFC, 3-phase motor. There you go, spinning, running, whatever. This motor is funny, nice and smooth. It's rotating as it should. Right now, there's a little three switches here. I'm gonna pop any of these randomly just to see now. It's different in the sound. This motor runs right now on 2 phases only. But it's still running. It's a rough, but it's a ride. When I turn off this fan, let me use my trustworthy brake. Okay, right now it's off. One of the phases is down. We turn them on. There we go. It won't start again. And that's the things what I was saying. 3-phase motor. We'll start on a 3-phase. We'll run on 2. Rough, but it will run. But it will not restart. One thing that I told our guys when they go, especially in the older restaurants, ask your manager to turn the fan off and turn them back on. That way, at least if something's wrong, they know that we didn't do it. And that's because one of those things that it's really hard to understand. Hey, it's 3-phase. Why it doesn't run or why it doesn't trip? Motion of the fan when it's spinning or motion of the motor when it's spinning will compensate for the missing leg. It will continue to spin, not stop until you physically stop. Therefore, on older fans, older applications, older restaurants, have manager turn that fan off, wait a few minutes, turn them back on to see why it doesn't work. Now we're talking about the motor frame, how to find out how we're gonna figure out what's going on. If you find the motor, that nameplate is missing, but it's still running, highly recommend to do this. This is called a touchless tachometer. It's not tachometer, it's tachometer. You put a little reflection tape on a shaft, turn the motor, have a laser count. And we now know that this motor running 1798 RPM. This one does have a nameplate. The nameplate showing 1745. That means we are within allowable difference between my meter and the motor himself. Record that information. That's going to help you later a lot. Second thing is vernier caliper. As we discussed on the frame sizes, one of the things is to measure the shaft size. Shaft size on this one, let me turn them on, helps a lot. It's showing the 7/8 shaft. This is the size of this shaft, 7/8. And if you look at the, sometime you'll find it engraved on your bushing. And this bush is showing the 7/8. Now, on the motor frame chart, that's a number under the U. This will get you to the basic shaft. Very few sizes sharing the same shaft size. Second one is to measure is basically footprint. You do have differences between the hole, mounting holes on the foot. You have a height of the bottom to the center of the shaft and differences between the shaft on top of the motor. All those information will help you determine the frame. Frame will put you in a specific horsepower with information that we talk about voltage and arm settings. You can get the correct motor size without having the nameplate. Only things that you get, it will be RPM, but the standard RPM for all our exhaust fans are either 1740 up and down the few or 3450. Very rarely, and that's mostly for the pump application that we don't deal with mostly, you'll find the 1150 or 1400. Those are not fan applications. The fan applications are 3450 for a high-speed fan or 1740, 1750 for the standard speed fans. Therefore, you know what your shaft size, you know what's the physical side of the motor. They'll help determine the frame. Voltage is known based on power supply. Amp settings can be found on a protected device. Based on that, you can pretty well guess what type of motor or what size of motor you need for application. Now, we talked about PFC motor not being suitable for everything. I want to show you a couple of motors, a couple of different frames. That's what's happening with them when they got to the wrong place.
Mario, there's a question in the chat. Would you like me to read that out to you?
Please do. I appreciate it.
What training programs, if any, would you recommend for someone getting into fan and motor installation / maintenance?
Okay. There will be, I will start with the HVAC, HVAC. There are pretty, because those dealing with the air movement. I don't care too much about refrigeration part of HVAC, but basic HVAC training, it's a good training about that. Also, there's some electrical controls or electromechanical. My degree, it's electromechanics. That's mean I was study controls and the motors, ins and outs of the motors. But I would say HVAC would be the best place to go.
Great, thank you.
Okay, now, this poor guy here, as you can see, It's all rusted and crummy and wherever. This was inside the evaporative makeup air, evap cooler. What's happened? As you can see, the buildup on the back. Moisture out of the media, get to it, and it died. I had a discussion with Captivate about it, and they told me that I'm crazy. And I fully agree with it. But I never put a DP motor inside the airstream when I have a moisture source of moisture right up the airflow. And this is one of the applications when the air over did not work very well. Second one that died, gruesome death. I got to bring it in because it's dirty. This motor here. You don't see this motor here. Let me do it this way. There you go. It's a Baldur ODP motor. How crummy it is, how dirty it is. Reason for that? It was in an airstream. Grease has a one bad property. It's acidic. Everybody heard probably for the term fatty acid out of our grease and how that affect everything around us. And you would say, you know what, how the grease and corrosion, how that goes. Animal fat is actually corrosive. This boy was inside the airstream. It gets so dirty inside that actually bearing ceased. You cannot move it. How bad it is. It just died gruesome death because of being the motor for the wrong application. Wrong motor for the application. It's just nasty. And this one's replaced with a TEFC motor for about 3 years now. Nothing happened. All running. Now, this is another motor that's coming more and more. All the ECM motors, or electronically commutated motor. This boy have a built-in VFD. It looks strange, it looks weird. It's a TFC motor, but it does have a component that controls the speed. Some of you did see this, some of you didn't, but it's coming more and more, especially with direct drive applications. This motor requires a special tool to adjust the speed, to deal with it. Some of these are actually Bluetooth. You can connect it with your phone if you have a proper software to do so, proper application. If you don't have, do not try to mess with it. Try to find out who is the manufacturer. If you get some information for them, leave it. Because it's very expensive. This motor, for instance, it costs almost $3,000 because it is specialized motor for application. Okay, this is a strange one. See this one? There's no mounting bracket. There's no footer. There's nothing. This is a C-faced motor. If you look at it on the motor frames, they have a 50 age C, but they have a C. C number means a C face. This motor is actually designed for the direct drive fence. Mounting goes to the top. Here, there's no footprint. This one does have a footprint area. I'll show you. Does have the rigid mount. This is mounted directly on the mounting plate, and beyond the plate is a fan. This is the only motor that is actually designed for direct drive fence. You can put any of these other ones, they will work. But they will have issues with vibration, issues with everything else from the contamination, except this. This is the only guy designed for that. Problem is, to put them on, it's easy. To replace them when they go bad, it's a pain in the lower back. I'll try to be gentle. It's really painful to do so. But that's the right motor for application. That's why it's the issue. That's why the designing the correct application, correct motor, correct horsepower, it's critical to extend the life of the application, to extend the life of the motor. Now, next one we'll talk about a little bit about what I'm saying, the wire nuts, how to warm wire nuts can damage the motor. This is the wire nuts. Everybody sees them. This is the wire nuts. This is a lug wire nuts that goes inside the housing. This is a 200 degrees rated wire nuts. This is a 320 degrees rated wire nuts. This one will not melt inside the motor. And I have a couple of wires here. I want to show you a couple of things, what to do with it. I just got a couple pieces of wire. Last, I can see what the hell I'm doing. I'll do my French. With the standard wire nuts, I'm gonna put the two wires together, and we're good to go. And we really don't know how good this connection is inside. We know it's there, it's gonna stay there, it's cool. Oh, pops out. That means it's prone to lose contact. It's prone to have an issue. Now, you do that with this one, that's different. You do have a metal cap that goes, it's a set screw, and it's a lock. Wire through it. And you screw it. Tie them up. You tie them with a screwdriver. Now this wire won't move. Yes, it will, because I didn't do right. My apologies. I just proved myself wrong. You do it, this cap goes over. This is how to stay. Now you can find the different sides of these wires, wire nuts. They're not all same size, but they're all same temperature rating. They are made by the same guys to make everything else. But this is called the lightning and motor rated wire nuts. It's very important to understand. Heating will burn these eventually. They get loose. This one will not. It's going to work way better. Now, basic tools that you need to play with the motor. We start with the clamp on meter, standard fluke, nothing fancy. Cost of $140 in Granger. Wire marker, Home Depot, $15. But every time you remove the wire, make sure you mark it, make sure it goes. Remember, that way you don't have to guess about it. Combination nut driver, Home Depot, little adjustable wrench, voltage tester. Okay, this is not a voltage meter. It's just tell you that there's something going on. Don't touch with your finger. Shut the power off. Do whatever you need to do to make it work. Don't play with it. So basically, you need a wire stripper. This one, some adjustable wrenches, and this basically the little needle nose. All of these is a Home Depot tool. Nothing really special. Nothing really things that you need to buy something. Oh my God, I need to spend so much money to get something. But most important thing is to understand what to expect for this, and make sure that this is set up correctly for the correct application, and that application will work awesome as long as this guy spins. Therefore, it's pay attention. Do not listen to what motors tell you. Do not try to improvise, because improvisation in this case can do a lot of damage to the place. Worst case of all, can kill you as an operator. Don't touch this when it spins. When motor is running, until it fully stops, do not approach the belts, do not approach the bearings, don't let them go, let them stop. Motor is not running, it's end of the world, it can be changed, can be fixed. You're not running, it's end of the world for you. Therefore, be careful, apply the maximum care, maximum self-protection when you deal with this kind of stuff. They're awesome, they can last for a long time. Respect them, don't abuse them, they're gonna serve you well. I'm open now for any more questions, I'll gladly answer. If you don't mind, April, if there's anything there, that will pretty much it on my side.
Hey Mario, it's Kathy DeMarco again. April is troubleshooting the next session, making sure we're ready to go. There are a couple comments in the chat. Richard Eckhart shared, often a mechanic will say water got into the shroud of an upblast despite the top cap being sealed well. Is there another location inside the shroud that can generate enough moisture to cause the motor to fail? Okay. And then Eric had a response. He recently ran into a greenback upbeats fan with an unsealed motor. The motor compartment had vent holes in the bottom, but it fried the motor during normal washing because the vents were not visible from either side. And he also said you may also have a vent tube on some older fans, and it's easy to get moisture in there if not careful.
Yes, that's true. Now that's why I personally choose for every fan operation with the grease. I prefer the totally enclosed motor over the ODPs. ODPs are awesome. They're way cheaper. But for us, I really do not like to see any motor, especially a blast fan. I do not like to see with the ODP motor. On a utility set, that motor is kind of outside the housing, outside they have a bell, so the shot goes in. That motor, more or less, it will survive everything because it's not directly exposed to anything. But blast fans, we need to lift them, we need to pop them up, we need to do this kind of stuff. Between the shaft and the motor is actually, there's no sealant, there's no air coming in. If you run a situation, the motor died because of water in, change it from ODP to TFC. That was the difference in the price is minuscule compared to the headache. I'll highly recommend every blast fan, every fan that we clean that is not utility set, to put the TFC motor inside instead of ODP.
Okay, great. So one more question. Well, just to back up. So Eric said he updated his post to green heck up blast. I guess there was a typo in his original post. So that's what he's talking about. Let's see a question. Do you measure in ohms when checking for a bad phase, or would you test for continuity?
Okay, you test it for continuity. It's basically when you have a voltage, you have 3 legs that comes into it, L1, L2, L3. You take the let me do this. Let me disconnect the power from this, and I'm going to measure for you to show what I'm talking about. How's that? But let me take the power out before it kills me.
That would be a great idea.
There we go. Now things is off, and I'll take the cover off so you can see how it looks like inside. It's the crowded inside. And by the way, this is a unique motor. This is a motor designed for US and worldwide market. And with different voltages, different all kind of stuff. This is like 16 wires things. You're not gonna see this many of them. Our Canadian guys see this quite often because this is a Canadian motor. Okay. Let me pop the cap off. And put the glasses on too, because that helps a lot when you see it.
Okay, well, while we're doing that, we are going to run maybe another 3 or 4 minutes. I know we lost about 10 minutes moving over to Zoom.
I'm sorry.
No, you're fine.
Oh, by the way, when I said that some of the stuff that we have, the wirings are on the nameplate, some of that inside the cap. but they're always provided. Now, when you pull out all these jungle the wires, there's a 3 wires that coming in. L1, L2, L3. What you do is you set up your meter. Even though this coming up in technical training, but I need to do this on continuity. And confirm that you do have one. Let's see how this is. Very good. As a point of continuity, let me hold it here that it's at least visible. You take L1 to L2. It shows you that it's 1.9 kilo ohm resistance between these 2 legs. Let's go L2, L3. It shows it's 1.7 resistance between 3 legs. L3, L1. It shows 1.7. Basically, they tell me right now that all 3 legs have a continuity between them, and resistance is about same. Therefore, this motor is okay. But if I have a 1.7, 1.7, and then the third leg it's 0.65, that's that point burn top that I said, the cut in between and a short top, it's still there. I can have a beep, but my resistance now is half of that. There's still is point burn. If you do not, if it's open constantly and you connect 2 wires and nothing happened, oh, this is open now, it might be completely burned. Therefore, in that case, it's bad. And you can smell that, believe me. Another way what motor can burn, it can burn against the ground. That's when you connect the 3 legs, any of the 3 legs against the ground and it beeps. It's a short to ground, it's a dead replace. Don't worry about it. Don't think about it. But when you do measure the resistance between the 3 legs, should show you about same resistance within 10% up and down. That will give you that what's happening with the motor windings. That's how we test it. Don't try to complicate. Don't try to look at it for the chart. What's the ohms law? Say no. Don't complicate. Everything in electricity, when it's run within 10% on nominal value, it will work. It's within an allowable spec.
All right. Hey, Mario, 1 more minute, 1 more question. 300-degree wire nut, name, info. Somebody was looking for what you call that 300-degree wire nut.
There we go. All I'm going to do is I'll take a picture of this and I'm going to post it. I'll send email to you. This is basically, it's made by Ideal. That's basically, that's the company making all of them. You just need to go on and specialize. If you have a McMaster and car, go there too. It basically looks for the set screw wire connector. That's a real name. It's basically
for 1 second. Set screw wire connector by Ideal. Yep. There you go.
Yep. And Ideal make all of them. Ideal make about 90% of wire nuts. But this is specifically for high temperature application. You can have that in an old lightning application when you have a good old mercury lights that heats up as hell. And on the motor applications, where it's hot inside, you want to make sure that you're good with it. Plus that set screw, it's a good thing because you can tie those wires. You can give them a good, nice tight. They will not get loose.
All right. Well, we need to wrap it up there. The next session starts in 10 minutes. Back on the Excel Events platform. Everything's been troubleshooted and hopefully we'll be kicking off that session. Thank you for your understanding and hopping over to Zoom. We appreciate it. Thank you so much to Mario and his team, who I'm sure helped support him there. And we will see you back over at Excel Events. Thanks very much.
And anybody, any additional questions, please send a message. No problem. I'll gladly help, gladly answer. Thanks, Mario. Guys, thank you.
Thanks, Mario. Bye-bye.